In our previous video, we learned about what atoms are and a general idea about how they look. Now we will take a look at the different type of atoms that exist in the universe. We have learned that hydrogen was the first type of atom in existence. It is also the smallest and the simplest. Overall, there are 118 different type of atoms. Out of these, 94 occur freely in nature. They were created by the universe in the last 100 millions of years. The remaining 24 are synthetic elements. These were created by scientists in the lab and they are not found in nature. We are only going to focus on 18 atoms for now. The atoms that we focus on are hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, and argon. These are numbered from 1 to 18. The number is significant because it tells us how many electrons or protons are present in that atom. This is called as the atomic number. For example, a native atom of carbon, whose atomic number is 6, will have 6 electrons and 6 protons in it. I will use this example to construct the atom. We know that there are two parts to an atom, the nucleus and the orbits. The nucleus houses the protons and neutrons. The orbits house the electrons. When we draw an atom, we don't draw the nucleus in detail. We only emphasize on the electrons in the orbits. So, the first step to drawing an atom would be to draw a circle in the center which represents its nucleus. We will not draw what is inside it. An atom can have more than one orbit but only one nucleus. The number of orbits depends on the number of electrons. More the electrons, more the orbits. Let us take a look at the orbits in detail. We will only speak about the first 3 orbits. The first orbit is called K. This is the smallest orbit right outside the nucleus. It can house only 2 electrons. The second orbit is called L. It is slightly bigger than K and it can house 8 electrons. The third orbit is called M. It is bigger than L and it can house 18 electrons. The next step is to draw the orbits based on the number of electrons of our atom. Orbits are filled 1 electron at a time starting from K. Once K is full and you have more electrons remaining, then we will draw the next orbit and start filling the remaining electrons there. Now for example, my atomic number is 6. I drew 2 electrons, but I still have 4 more electrons. Now I will draw the second shell L. Now L can hold 8 electrons and I have 4. So I will put all 4 electrons in this shell. Count all the electrons. There are exactly 6 with 2 in K and 4 in L. I have drawn them in the correct order while keeping in mind the total number of electrons and the maximum number of electrons that can fit inside these shells. Repeat this process until you have drawn as many electrons in the correct order as the atomic number. Let us now take a look at how to draw helium atom. Now helium's atomic number is 2, which means it has only 2 electrons in it. Now the first step is, as usual, I'll draw the nucleus in the center and then I will add the first orbit, that is K. Now K holds 2 electrons and I have 2 electrons only. So I will draw both of my electrons one at a time in K shell. Now all my electrons are done. So helium simply has one shell with 2 electrons. Now let us take a look at sulfur atom. Right? Sulfur's atomic number is 16. That means 16 electrons in a sulfur atom. Now, first thing, we draw the nucleus in the center. Next, we draw the first shell, that is K. Now, out of the 16, the first 2 electrons are going to go to K shell. Now, K is full. So now I need to move to the next shell, that is L, because I still have more electrons to draw. Now, L can hold 8 electrons. So I'm going to draw 8 electrons out of the remaining in L shell. Now L is also full. I'm done with 10 electrons, but there are still 6 electrons remaining. Now after L, I'm going to draw the third shell, that is M. Now M can hold a total of 18 electrons, but I only have 6 more electrons remaining. So I'm going to draw all the 6 electrons in the M shell. This is what a sulfur atom looks like. Now this model of an atom was introduced by a scientist named Niels Bohr. I encourage you to choose any atom from this list and use the same steps to draw it. In the next video, we will attach an image with the diagram for all of these atoms. Stay tuned for more. Thank you and stay curious.